Hi students, welcome to Physics Truth Loka channel. Today we shall discuss about a problem related to distance of closest approach. So in this distance of closest approach, you see in this problem two cars are there, car 1 and car 2. Both cars are moving at the same speed, that is 40 km per hour. Car 1 is moving towards east with a speed 40 km per hour and car 2 is moving towards north with the speed 40 km per hour. And initially at time t is equal to 0 seconds, both the cars are in this at initial separation 100 km. Now, see, this car 1 and car 2 are moving relative to each other. See, after some time, suppose after 1 hour, car 2 will travel a distance 40 km towards north, and car 1 also travels a distance 40 km like this. So, car 1 position after 1 hour will be here, and car 2 position will be here. But car 2 position will be here. But car 2 position will be here. Like this, at some instant of time, both the cars will have some minimum separation between them. So in order to find that minimum separation or distance of closest approach, we can find in normal way also, but here we are going to solve this problem by using the concept of relative velocity. So by using the concept of relative velocity, we know that velocity of first car, this is first car and this is second car. Velocity of first car as seen by second car, that is with respect to second car. So whenever we are saying with respect to second car, we will assume that second car will be at rest, and we will add the second car's velocity to the first car in negative direction, in opposite direction. So if we find v1 bar minus v2 bar, v1 bar is in this direction, v2 bar actually in this direction, but minus v2 will be in this direction. So if we add them by using parallelogram law of vector addition, we got this is 40, this is 40, and they are at right angles. So we will get, according to parallelogram law of vector addition, we will get 40 root 2 km per hour. That is, we can write this is square root of v1 square. You can find the magnitude of v12 as like this also, square root of v1 square plus v2 square plus here plus 2v1 v2, or we can write minus 2v1 v2 cos 90. Cos 90 value is 0, this term will be vanished. So we'll get v1 square plus v2 square. Square root of 40 square plus 40 square, you will get 40 root 2. So directly I wrote here the value. The velocity of first car with respect to second car is 40 root 2 km. Now see, this is the position actually. See, this is first car and this is second car. Second car we are assuming it rest. And for second car, first car is now traveling in this direction with a speed 40 root 2 km per hour. This is the velocity of first car with respect to second car, or as seen by second car, at an angle 45, because when equal, both are traveling with the same speed 40 at 90 degrees angles. So the resultant will bisect the angle between them. So the resultant, that is velocity of first car with respect to second car, is making an angle 45 degrees with the line joining both the cars. So now in this direction, first car is going with the speed 40 root 2. So in order to find minimum separation between the cars, or distance of closest approach between the cars, when the first car comes here, if you draw a perpendicular line for this, say second car is here. So in this direction, if first car is moving, so in order to find the shortest distance of separation between those two cars, we have to draw a perpendicular line for the line of motion of the first car with respect to the second car to the second car. So this is the perpendicular line, and this distance will become the shortest distance between the two cars. So in order to find this, from this triangle we can find sin 45 degrees is equal to, sin 45 means opposite side by hypotenuse. So in this right angle triangle, opposite side is S minimum, and this hypotenuse value is 100 already given. So if you cross multiply S minimum, you will get 100 sin 45, and sin 45 value is 100 into 1 by root 2. If you rationalize with root 2, then you will get 50 root 2 kilometers. So 50 root 2 kilometers is the shortest distance of separation between these two cars. And if you want to find after how much time this shortest, the first car will come to the shortest distance for the second car. So the time you can write time is equal to, generally you know, time is equal to distance by speed. So this distance by the speed 40 root 2. This distance is in this we can write 100 cos 45. If you find cos 45 adjacent side, uh, this distance, this distance, this distance is equals to cos 45, 100 cos 45 by 40 root 2. So 100 cos 45 again you will get it as 50 root 2 by 40 root 2. Root 2 root 2 gets cancelled, pi by 4. This is the time of this is the time taken by the first car, or this is the time for both the cars to reach to the minimum separation or distance of closest approach. Thank you very much.